Okay. So in a classification problem in general, we're trying to train the network to assign a category label to every sample, right? Classification problems often structure their output the way that we did, right? Each category that we care about has one element in the output, and we interpret the value of that element as being the probability of membership in a given category, right? Probability of membership, right? So the training set we can label like this because everything in the training set we can assign an unambiguous category to, right? We know with perfect certainty in the example of sort of the unit cube problem what label every point should have. Our network's output might end up looking something like this, where these are relative probabilities that a point is in the outermost one as opposed to one of the inner ones, okay? When the network gets unknown input, it is likely to produce output kind of like this, right? Where every one of those is a probability of belonging to a given category. So the training input there was an example of a one-hot vector. A one-hot vector is a vector where exactly one element is 1 and everything else is 0, right? So 1, 0, 0, 0. One-hot vectors are often used to represent category labels, that is, the outputs in a classification problem. They are often also used to represent, for example, IDs in language tasks, right? So we might assign, so if we're doing a language task, we might pick the 500 most common words, and then we might represent our input as the ID of a given word, right? So when might be the 50th most common word, and so we might represent it to a neural network as a one-hot vector of length 500, where the 50th item is 1 and everything else is 0. Okay? So that's a one-hot input, and those category labels are one-hot outputs.